Hello and welcome to Education at SSBJ online video tutorial. We shall straightway take a question from chapter Motion of class 9th, and the question reads, what kind of motion following graph represents? So there are two graphs given. Carefully observe the graph. The first graph A is speed versus time, right? Speed against time. And the second graph is distance against time, right? So just look at this y-axis and the x-axis and the physical quantities which are represented on these axes. So question is, what kind of motion following graph represents? Calculate speed of the body between 1 second and 4 seconds of graph B, right? Next question is that the graph given below shows the positions of the body at different times. Now this graph, when you look at this, you have to first see what is a y-axis represents and the x-axis represents. Y again is a distance and x is representing time. So there are some questions which are given. Calculate the speed of the body as it moves from A to B, then B to C, and third one is C to D. These two graphs are very important as far as your examinations are concerned. After all, this is related to the chapter called motion, right? You have already learned the definition of motion. When do we say that body is in motion? As I have already told in the previous video, that if the body moves with time, okay, if the body moves with time, or if the body changes its position continuously with the time, then we say that body is in motion. Now let us take an example, right? A car is moving, right? And it moves for some distance. Now let me take the distance on the top. Here I will take a distance and then time I will write here, right? And then I will just use some divisions to represent time. Let's take this is 1 second time, right? When a 1 second time gets over, a car covered a distance of 1 meter, let's assume, right? And for the next second, one more second passed on, so second. So remember that after 1 second, one more second has gone, so I have written 2 seconds. And how much of distance is covered? From here 2 meter distance is covered. That means from here 1 meter distance is covered, right? In the same way, third second, again 1 meter distance is covered. Look at this figure, 2 meter and 3 meter distance is 1 meter distance. And then 4 second and 5 second, so on. Suppose if the car moves in this way, right? Let us analyze this situation. Look at this. In the first second, between 1 and 2 seconds, how much of distance is covered? 1 meter distance is covered. In the same way, between 2 meter and 3 meter, how much of distance is covered? 1 meter distance is covered. In the same way, between 3 and 4 meter, how much of distance is covered? 1 meter and 1 meter. Look at these numbers. Look at this number. 1 meter distance for every second. And how much of time varies here? From here to here, right? How much of time? It's 1 second. Then from here to here, how much of time? 1 second, and so on. For every small interval is of 1 second. That means overall we can say equal distance is covered, right, in equal intervals of time. If a body covers equal distance in equal intervals of time, I am repeating again, if a body covers equal distance, look at this, 1 meter, in equal intervals of time, however small these intervals are, right, then such motion is called uniform motion. Right? If the question is asked for the exam to define uniform motion, you should remember two important words. One is equal distance and another is equal intervals of time. You can even underline in your definition, like a body has a uniform motion if it covers equal distance in equal intervals of time, no matter how small these time intervals may be. If you write your definition in such a way that keywords, if you underline them properly, then that is giving you a good impression as far as your exam scores are concerned, okay, as far as evaluator is concerned, right? So let us bring down this entire picture to one corner now, and I hope you can see these figures properly. The same thing which you have already seen. What I am going to do, I am going to write the same thing in tabular columns. So one side I will write a distance, another time, another side I will write a distance. For example, when the time is 1 second, how much of distance is covered? Let's say 1 meter. Okay. So when time is 1 second, so 1 meter distance is covered. Right. For the second second, 2 meter distance is covered. For the third one, again, total distance covered is 3 meter, and so on. For the fourth second, 5 meter. You can even write 5 second. This is 4 meter. Right? This is 4 meter. And the fifth second, it will be 5 meter distance. We need not take this. We will take only these 4. Right? Now, if you want to calculate what is the speed here, you have learned the definition of the speed. And what is the definition of the speed? Speed is distance traveled in unit time. Right? In smallest amount of time, how much is the distance covered by this car? Is the speed of that car. Right? So the speed can be given by the formula. Look at this. Distance traveled divided by total time. So in short, I am writing distance divided by time. Right? So this is the formula to find the speed. This is the definition of the speed. Since distance is measured in meters and time is measured in second, meter per second is the SI unit of speed. So remember this. So we can express this distance by time, that is speed, in terms of SI unit, that is meter per second. Let us now calculate what is the speed. So whatever is written below this here is the speed. So how much is the distance for the first one? 1 meter distance. Time is 1 second. So 1 divided by 1, that is going to be 1 meter per second. So speed of this object or a car somewhere here is 1 meter per second. In the same way, the second one is distance is 2 meter and in 2 seconds. So from here to here, when it covers a distance in 2 seconds, how much of distance it is covering? It is covering 2 meter distance. So 2 meter divided by 2 seconds, 1 meter per second. I hope you are understanding these calculations properly. In case if you feel that I am moving a bit fast, you can pause this video and work out on your own and then continue. The same way, in third second, from here to here, in third second it covers 3 meter distance. Therefore distance divided by time, 3 meter divided by 3 seconds is equal to again 1 meter per second, and so on. Fourth second also it is 1 meter per second. Look at this. Look at this. The speed remains same. So what is our observation? If a equal distance is covered in equal intervals of a time, if equal distance is covered in equal intervals of a time, then the speed remains same. Right? So we can say that since the speed is same, or we can say speed is constant. That's a better word, isn't it? And therefore speed of the moving body in the uniform motion. If the body moves in uniform motion, and what do you understand by the movement in uniform motion? Covering equal distance in equal intervals of a time, and then what happens? The speed remains constant. So that's why it is written, speed of the moving body in uniform motion remains constant, right? So that is also called uniform speed. The meaning of uniform speed is constant speed. So remember this, constant speed, right? So suppose if the question is asked, define uniform speed, you can write the definition in different ways. For example, if a body has a constant speed throughout its motion like this, then it is called uniform speed, right? Or if a body covers equal distance in equal intervals of a time, look at this definition. Both are same, but words are different. If a body covers equal distance in equal intervals of a time, then the speed of the body is uniform speed, right? Or even uniform speed is the speed of a body which is moving in uniform motion. All are same. Okay, you stick to this. This is better and gives a detailed explanation. If a body covers equal distance in equal intervals of time, then the speed of the body is called uniform speed. Right? So we'll stick to this definition. Now let us do some graph work. Let me take a graph here. However small in size this graph is, I am keeping this graph here because let us have all the information on one slide. Okay, so what are the y and x axis? So this is y axis and this is x axis, and now we are going to look at this distance versus time graph of uniform motion. So this is the uniform motion. For that uniform motion we have the values here, 1 second, 2 second, 3 second, and respectively all the distances, 1 meter, 2 meter, 3 meter and 4 meter. So we shall see distance versus time graph, right? So time will be generally taken on x-axis and time will be in second. Look at this, time will be in second. I have written here already, and therefore the distance versus time graph, here the distance will come and distance will be in terms of meter, right? Look at this, time is in terms of second and distance is in terms of meter, right? Let us now find out here. Number 1, 2, 3, 4 continuous seconds are there. 1 second, 2 second, 3 second, 4 second, and it's very easy for us to mention 1 second, 2 second, 3 second and 4 second. And here also, here we have covered 1 meter, 2 meter, 3 meter, 4 meter. It will not be always same, but to make it simple we have taken this example. So 1 meter distance here, 2 meter distance here, and then 3 meters and 4 meters. Okay, so that is the. Now what we have to do is we have to take this tabular column and incorporate this value into this graph, right? So we'll take these values now. The first value is for 1 second, it goes for 1 meter, therefore this is 1 second and 1 meter. So here the dot comes. In the same way for 2 second, how much of distance is covered? 2 meter, 2 is here, and 2 seconds 2 meter. Look at this, dot has gone little up. For the 3 second, 3 meter distance, and for the 4th second 4 meter distance, right? So therefore our graph becomes a straight line. So what is the conclusion? Distance versus time graph of uniform motion is a straight line. So please remember this. This is the information which is related to the question we have taken in the first slide, which is in the start of the video, right? Now please remember, distance versus time graph of uniform motion is a straight line, and the straight line is not parallel to either y-axis or x-axis. Okay, now what we do, in place of distance we shall take speed versus time. So speed versus time graph. Okay, the earlier one is distance versus time graph. Now it's a speed versus time graph of uniform motion only. And therefore, we should take on one side speed, and that is in meter per second, and another side, that is on x-axis, time in second only. So this remains same. Now look at the values. So what all the values should I take? Should we take time and distance? No. Distance we shouldn't take, we should take speed, because it's a speed versus time graph. So we'll take this speed as well as time. For the first second, right? For the first second, what is the speed? The speed is 1 meter per second. So for the first second, speed is here 1 meter per second. Right? Please try to understand. For the second, speed is again 1 meter per second. So it doesn't go up. For the third second, the speed is again 1 meter per second. And for the fourth second, the speed is again 1 meter per second. So we have taken, please remember, we have taken speed as well as time. One side speed, another side time. Speed is in meter per second and time is in second. So if you join these dots, you will get a straight line which is parallel to the time axis. Right? And therefore, what is the conclusion? If you find a straight line graph when you draw speed against time, then what kind of motion is it? Uniform motion. Again, this information is useful to answer the question. And what are the questions which we have taken up in the start of the video? And our question is here: what kind of motion following graph represents? Right? Go back. If in the time, if the speed versus time graph, if you find a straight line graph which is parallel to time axis, look at this. One side y-axis speed and x-axis time. So y-axis speed and x-axis time. And if you find a straight line graph parallel to the time axis, then what kind of motion it is? Uniform motion. You should not write uniform speed, because what kind of motion is asked? So uniform motion. So we have already learned that if the speed remains constant, how much is the speed here? 1 meter per second. How much is speed here? 1 meter per second, 1 meter per second and 1 meter per second, right? Okay. Now, next one. Look at this graph. For 1 second, 1 meter distance is covered. For 2 seconds, 2 meter distance is covered. Again 1 meter only. For 3 seconds, again 1 meter distance is covered. Equal distance is covered in equal intervals of time. And what kind of motion it is? Again uniform motion. So please remember, when you look at the graph, what you have to do is first look at these x-axis and y-axis, what is written here. Okay, therefore you will immediately understand this is the graph which is of uniform motion, and this is also of uniform motion. However, they are different because they are drawn for different values of distance and speed, right? But sometime, we have got the entire x and y axis here. The plus and minus quadrant are also given here, but generally in the examination only this particular part will be shown to you. It is this way, right? So therefore don't get confused. Look at this. I have taken here a complete graph, okay, but in the exam what they'll give is this graph, right? Now we'll go for the another question which we have taken up in the starting. The graph given below shows the positions of the body at different times. Calculate the speed of the body as it moves from A to B. Well, so A to B, and look at look at I'll just give you a hint here. From A to B, how much time it has covered? 1 second, 2 second, 3 second. So remember, from 2 to 3 1 second, plus 3 to 4 1 second, plus 4 to 5 1 second. So total time how much? Time is 3 seconds. How much distance is covered? From here to here 1 meter, again here to here 1 meter, and here to here 3 meter. So here it ends. So what is the distance? I'll use D only, or you can use S also. Distance is 3 meter, and therefore speed can be distance divided by time, which is 3 by 3 is equal to 1 meter per second. Very simple. Now, what is the speed of the body from B to C? Right? Now, look at this. On 5th second, body is at 3 meter. On 6th second, body is still at 3 meter. 7th second, body is still at 3 meter only, which means this object has not moved further. It covered a milestone of 3 meter at 5 seconds. It was there at 6 seconds. It was there at 7 seconds without movement. Time gone up, but distance did not cover. Therefore, here the speed is 0. Right? What about the speed from C to D? So look at this. C is 3 here. From 3 to D. So 1 kilometer, 1 meter. Right? Sorry. I have to take it in centimeters. Sorry. You have to take in centimeters. Please consider that. So it is centimeter per second. Speed is in centimeter. So not to make this error, units are very important. So this is 3 centimeter, 3 seconds. So it becomes 1 centimeter per second. In the same way here 0, and in the same way from here to here 1 centimeter, 2 centimeter, 3 centimeter and 4 centimeter. So remember here from here to here it has covered 4 centimeter, and how much of time? That means it starts from here and it ends here. It is covering 2 seconds, right? So 4 centimeter in 2 seconds. Okay, and that is why the speed is equal to distance divided by time, which is equal to 4 centimeter in 2 seconds. So speed is equal to 2 centimeter per second. Okay, since they have given this in centimeter, so you have to express in centimeter per second. That is what the discussion of those two questions which we had taken. We have learnt many things regarding the graph as well as the calculation of speed and understanding the speed, time and distance time graph. Thank you very much. Keep in touch. Thank you.